Namaskar. I'm Priti and I welcome you all to our live and interactive session. You are watching us on PME Vidya channel number 8 and also on our YouTube handle NCERT Official. This session is meant for us students of class 8 and the subject that we are taking up is science. We're going to learn about chapter number 10 of your textbook titled Light, Mirrors and Lenses. This is going to be part 1 of this particular session, and in this session we will be focusing on light. We'll be learning about mirrors and lenses also, and we will be entertaining questions from your end as well. So if you want to get in touch with us, please take down the details. Our phone number is 8800440559. Our email ID is tth.class8@ciet.nic.in. And on our YouTube handle NCERT Official as well, you can send us your questions, suggestions, your feedback or any problem that you might be encountering in learning the chapter. Now for this session, we are joined by our experts. So please welcome Ms. Priti Maan, Ma'am is TGT Science from Bharati Public School, New Delhi. Ma'am, namaskar and very warm welcome to the session.
Thank you, ma'am.
And we both are accompanied by our Indian Sign Language interpreter, Ms. Sonal. Ms. Sonal, namaskar and very warm welcome to the session as well. So ma'am, since it's going to be part 1 of the particular chapter, I want to understand from you what all you'll be covering in the session today.
Alright, so we'll start from what students have studied in class 6 and 7 because it will be just random if we start the chapter with the content that is given. So we'll quickly touch on those concepts. Then we'll talk about these mirrors, the types and how they form their image. Okay. And then after that we'll be talking more about the kind of image they form. So this will be the flow of the chapter.
Right, ma'am. And ma'am, since the topic itself says light, mirror and lenses, so let's start with light only. I want to understand how light travels. I'm sure it travels through vacuum as well.
Yes.
Because in space there is nothing but we still get sunlight. So just let us know that how does light travel?
So that's what children study in grade 6, right? That there's an experiment also, beautiful experiment, that light travels in a straight line.
Okay.
Wherever it is traveling, it is always traveling in a straight line. So what do we do in that activity? We keep a candle flame, right? And then we just take a straw. I'll just show you how it is done.
Okay.
And through the straw, we see like this. And then we just tilt the straw.
Okay.
Now the flame is not visible. Okay. So when this is complete straight, the straw is completely straight, you can see the candle flame.
Yes.
So this property is called as what? Rectilinear propagation of light.
Okay.
That light always travels in a straight line. Right. That's how this goes with always straight.
Okay.
Right. So that is the property.
And
Next.
now, let's talk about the mirror because I wanted to come and you've already shown the PPT as well. So tell us about the mirror. The mirror that we're talking about here, is it the plain mirror that we have in our homes?
Yes, the same. So I would like to ask you a question that whenever you see yourself in mirror, right, what do you find out?
I find a change. I find that left becomes right and vice versa.
Okay, that's one of the properties. What else?
What else? I see myself, so means it reflects
the
light.
It is reflecting light. That's the reason why you're able to see yourself. So we'll quickly touch up on the characteristics property of a plane mirror. Okay. So everybody has seen a plane mirror. The mirror available in our houses, it's a plane mirror.
Yeah.
Okay. So the image form in the plane mirror, it is upright. So we stand like this. Our image also is the same way.
Yes.
It is upright, right? For reference, you can see these ducks. If this is the object, so the image is upright.
Yes.
Right? Now, second is, it's of the same size.
Oh yes, certainly.
Okay?
Yeah.
But we do have certain mirrors where the size changes.
Where you look either too fat or too thin.
We'll do talk about those also. But for plane mirrors, what happens? The object remains same size. Next, we have the image is laterally inverted. Like you said, the left appears to be right and right appears to be left. This property is called as lateral inversion.
Okay.
And the distance, whatever is the distance between the object and the mirror, right? So, object and the mirror, same will be the distance of the image and the mirror.
Oh, wow.
If you are, say for example, if you are standing 30 centimeters or say 1 meter away from the mirror, your image also be 1 meter inside the mirror.
Wow.
So these all are what? These are the characteristics, property of the image formed by a plane mirror. So here I just want to, okay, upright, I'll show you this, that how this image upright means. So we'll use the arrows.
Okay.
Right? Here is the plane mirror. This is the object. If image is upright, then it looks like this.
Right.
This is also called as an erect image.
Erect image, okay.
There's one more condition wherein the object is like this and the image formed is upside down. Okay. This image we call it as inverted image. So we should be ready with the vocabulary so that when it comes later in the chapter, we know what does it mean, right? If the image is like this, okay,
erect image,
and if it is getting upside down,
inverted image,
it is an inverted image.
Okay. So ma'am, you just mentioned a while ago that there are different kinds of mirrors also, other than those we have in our homes or that we use generally. So what those mirrors are called?
Yes, so we did pick up that example that in some mirrors, like when we go to a maze, what happens? Somewhere we look inverted, somewhere we look fat, somewhere we look thin. So why that happens? That happens because of various mirrors which are available. Right now, if we talk of spherical mirrors, now spherical mirrors are what? They have that reflecting surfaces. They are the part of spheres. Okay, so we'll quickly draw that also.
All right. So these mirrors are called spherical mirrors.
Spherical mirrors. Why we call them spherical mirrors? I'll show you the reason.
Sure.
So if we say this whole sphere, right? Now it has got two surfaces. One surface is it's making a cave like this one. So you get a cave like and mirror
the
if
outer.
We are talking of, so mirrors are polished from one end. Yes, one side is polished. So by these linings we show the polished surface.
Okay.
The another one is this part, right, which is outward. Okay. So for this one the polished surface is this.
Okay. Okay.
And when this is divided, we get two mirrors. This one is one type and this one is the another type. Right? So that's the reason. Now here we can take an example of a spoon.
Okay.
Right? So spoon has both the ends, we can say this. You have this one that is bulging out. Right? And there's a curve in the spoon.
Yes.
So this part, which is like the inside part where we take the food, that is forming a cave like.
Yes.
Okay, so this part is called as concave.
Okay.
And the other part is called as convex.
Wow, so it's very interesting and it's easy to learn this way.
Right. I just want you to just look yourself both the sides and I'll ask you the question later.
Oh, okay. So let me see my image in the spoon. So here is the cave side, concave side, okay. And then is the convex side. All right.
Okay.
Yeah.
Now further, if we talk about the types, right, we have seen what are the types. So first we have concave mirrors and the convex mirrors. So we'll quickly see how they are different from each other.
Sure.
So reflecting surface we have seen for concave, the reflecting surface comes outside. Now in this picture also you can see over here in this image. So the reflecting surface is outside and here it is making a cave like thing. Okay. Here also. This is what is your
concave.
Yes. Right. So always remember concave means you have a cave from where the light gets reflected. Right. Next is, if we see the definition, so a spherical mirror where the reflecting surface curves inwards. So the inner side of the spoon, that's why I took the example of the spoon first. Next one is reflecting properties. Now this is something very important. What it does, it tends to make parallel rays converge at a point. Now in this case, when you see, these are the lines or these are the rays coming from an object. What is happening when they are reflecting back? Okay, they are meeting at a point. Okay, so what this property called as converging of light. So the light rays, they are coming from a source. After hitting the mirror, what happens to them? They come, all the rays, they come together at a point. So we call them as they are getting converged.
So point of convergence.
Yes.
Okay.
Now next we have, okay, so you have seen your image.
Yes.
How it looked like.
Okay.
Inside it is.
From the concave side, it was inverted.
Inverted. So we have seen what inverted means, that the image was upside down. So everybody, you can just quickly check in your in the spoons that when you see it from the inner part, from the curved part, you will see yourself upside down like this. Your head will be downwards and the body upwards. So that is inverted image. So concave mirror, it is forming an inverted image. Right. Now moving ahead, we have next as convex mirror.
Okay.
Now convex mirror is the outer curve.
Right.
Right. So now in this case, this is the reflecting surface, the outer curve, and inner, this is the polished one. Okay. Now outer curves is a reflecting surface, that goes in the definition. Now the reflecting property. In previous case, we have seen that the light rays are getting converged. In this case, what is happening? The light rays coming, hitting the mirror, and it is going back. Okay. So they are getting diverged. So light rays coming, hitting the mirror and going back. Now in this case, what is happening? To get the image of an object, these rays are extended back and at a point they are meeting and we get an image. But exactly what is happening, to be more precise, I'll just draw a diagram what exactly happens in here. So when the light rays are converging, so light rays are coming. Okay. Now here we have our mirror. Light rays are coming, and all of them, what is happening? They all are meeting at a
point.
Same point.
Yes.
So all these rays are getting converged. Now next is, this is our convex mirror. Now when light rays are coming and hitting the surface, what happens to it? They are all are getting in different directions. Right? So this is how the light rays get converged, and here the light rays are getting diverged. Okay, so remember this also, for concave mirror, converging mirror, and convex mirror is a diverging mirror. It diverges the ray of light.
And there is no common point in case of divergence.
Yes.
Okay. Only we have point of convergence where all rays meet after hitting the mirror.
Yes.
So you mean to say the mirrors that we have at home, they have light diverging?
In that case, yes, reflection is taking place. Okay. In that case, because we are getting our image as it is, okay. So what is happening? Some sort of divergence is happening, not to the extreme. Okay. Now if we talk of the image formed, so you just need to turn the spoon and look yourself. So you will look the way you are sitting.
Erect image.
Erect image, right? See, so that's why I've told the words before, inverted and erect. Now points to remember: concave mirror, the light rays are getting converged, and the image formed is inverted. You can write it. And in case of convex mirror, what happens? The light rays are getting diverged and the image formed is
erect. We can also understand it better through a slide of yours.
Yes. Now we'll see the image formed by concave mirrors. Now if we talk of concave mirror, so concave mirror has 6 different cases. Okay, 6 different position of object wherein you find the image formation is taking place. Now majorly we have seen what happens in case of concave mirror. It will be diverging the light that is coming from the object. So on the screen you see there are 2
spaces.
Yes. So one we have when the object is close. Okay, close to where? Close to the mirror, right? In this case you see object is here, close to the mirror, this is the mirror and here is the object. In this case you see the object is far from the mirror. Okay, so okay, now it will be more easy to understand. Now, so when the object is close, what will happen? That is this only case. I told you there are 6 conditions wherein we find that how in different conditions the image formed by concave mirror is different. So this is the last condition. This figure is the last condition wherein we find that when the object is so close to mirror, it forms an erect image, right? Just now we have seen concave mirrors, majorly they form inverted image.
Yes.
But in this case, when the object is placed close to mirror, it will be forming an erect image and it is an enlarged image, larger than the object.
Okay.
Now the other case, if the object is far, right, in this case you see the object is far, now light rays are coming, hitting and getting converged. The image is formed right here. So this image is inverted one. Okay. What happens? Now you just see the object, the size of the object and the size of the image. So it is comparatively small.
Yeah.
In this case, the image is larger than the object. So what I am trying to say here is when you change the position of an object in case of concave mirror, right? So concave mirrors will quickly have a look also. So this is a concave mirror, right? How do we
these the mirrors
identify?
that are used in vehicles?
This one is used in by dentist.
Okay, by dentist. Okay.
Yes. So concave mirror, it is how do we identify it just by touching? Okay.
Yeah.
Yes, just by touching it, we have seen that it has that
It's protruding.
out.
Out, yeah.
Okay, so that touch can tell. Okay, you can just check it also.
Yes. I can see the side that, this is the side that's painted and this is the side that's plain mirror and it's protruding out. So yeah, it's forming a curve.
Yes.
Like that.
So when we keep the object in at different positions, starting from the infinity to this last wherein the object is placed near to the mirror, we'll find different positions, different sizes of the image.
Okay.
Okay. And like I told you, where they are used because of their converging property, they are used by dentists. So to see the enlarged image of our teeth.
Yeah.
Okay. Now moving ahead, if we have seen the image formed by concave mirror, we'll also see the image formed by convex mirrors. Now in this case, what happens? That image formed by convex mirror is consistent. It always form an erect image.
Okay.
Unlike concave mirrors wherein the size and the nature was changing when we were changing the position of the object.
Got it.
In this case, what we'll get the erect image, right?
Right.
And next is what? The size is always diminished. It will be always smaller than the object. Now in this case, we did discuss that what happens with the light rays, they get diverged. Right? So you can see here the light rays are getting diverged.
Right.
And if this is the object, you see the image formed here. It's very small, tiny. Now where it is used, so this is the one which is used in the vehicles as a rear view mirror.
Oh, okay.
And also for surveillance, you must have seen these are different tones.
Yes, yes.
Yes. So these are installed wherever we have that sharp bends.
Great.
So
All
to
right.
remember, these are what? These are convex mirrors.
Convex mirrors, yeah, because concave can change the properties as far as image and the size is concerned.
Yes.
But in the case of convex, it remains the same. Okay. And now, because we are reaching the climax of the session, we have very little time left. I want to understand about one more thing before you actually leave us. You talked about mirror and you also talked about reflection.
Yes.
How the two are related.
See, mirrors, they are what? They are the surface which is polished, which is shiny. Okay. And reflection is what? It is bouncing back of light from a polished and a shiny surface.
Okay.
It is not always that in mirrors only we are visible. We are even visible at shiny car surfaces also.
Yes, even in spoon.
Yes, even in spoon, because the surface is smooth, it is
Lustrous
shiny.
also, yeah.
Right? So wherever the surface is smooth and it is shiny, we are able to see ourselves because the light is getting reflected.
Okay.
Okay. And if we talk of rough surfaces, there also light is getting reflected, but the pattern is irregular. That is the different types of reflection if we talk of. Okay, so reflection is what? Bouncing back of light. It further has two types, regular reflection and irregular reflection.
Right.
Regular reflection, when it is happening, we are able to see ourselves, like in case of mirrors. Okay, we are not able to see ourselves through the wall or on the wall,
Of course.
because the surface is
Opaque,
irregular
yeah.
there. Okay, so that's what is the difference between regular and irregular
Right.
reflections.
So, because now we're left with just 1 or 2 minutes, so I think there is no point in talking about the next topic, which is going to be laws of reflection.
Yes,
it's going to be a
yes.
very big topic, so we can take up in the next session. But if you can give us a quick recap of what we have learned today, that will be great.
So first, it is the properties of plane mirror. We need to be aware about the terms, because we look in the mirror every day, but the terms are important. First, the image is erect, right? Erect is upside down.
Right.
Second, the image is laterally inverted. Your left appears to be right, right appears to be left.
Right.
Okay. Then it is of same size and same distance.
Okay, great. So after these quick points of recap, it's now time for me to say thank you to my expert. I have to say that, I learned these concepts really nicely in this session. And never have I ever learned it this way, even during my childhood. So thank you so much for your time and for such an excellent explanation. I would also like to thank my ISL interpreter, Ms. Sonal, for her contribution to the session. Thank you so much, Sonal. And now we are wrapping up this session of light, mirrors and lenses. That was the conclusion of part 1. We will be taking up part 2 shortly. And what's coming up next? Let's take a quick look there. So here is the program schedule. In a short while from now, you can watch another session of ours that is going to be on mathematics. So please make sure you participate with this. It's a wrap. This is me, Priti, signing off. Namaskar.